Hello everyone. Have you ever wondered how we can separate the intricate mix of dyes in an ink? Today, we are going to master the advanced technique scientists use for separation, column chromatography. Let's dive in. Chromatography was developed in 1903 by the Russian botanist Michael Tesvet. The name comes from a Greek word, chroma, meaning color, and graphin, meaning to write. Today, it helps in separating complex organic mixtures and purifying chemical substances. Let us first get acquainted with the word adsorption. Adsorption is a surface phenomena where molecules from a fluid adhere to a solid surface. Common adsorbents include silica gel and alumina, which have high surface area and controlled polarity. Now let us look at two important phases in column chromatography. The stationary phase, which is a solid adsorbent and is static. The mobile phase is the liquid solvent or eluent which moves through the column carrying the sample mixture with it. To understand the process of column chromatography, let us consider the analogy with the racetrack. Stationary phase as the sticky track, mixture as the runners first stationed at the starting line, the moving phase as the wind which pushes the runners further. Now, as the race begins, the runners separate based on their affinity to the sticky track. Those that stick more to the track move slowly, while those that don't stick much move fast with the wind and win the race. Hence, they get separated at different distances. Thus, the core principle of column chromatography is differential adsorption. That is, components separate based on the relative adsorption to the stationary phase versus the moving solvent. Components that are highly adsorbed to the stationary phase move a shorter distance, whereas the component that is less adsorbed move larger distance and hence separate as bands. Here is the apparatus setup. We have the vertical glass column containing the stationary phase, generally silica gel. At the bottom, there is a tiny porous plug, often made of glass wool or cotton. Its job is simply to hold our solid in, but let the liquid flow. Below this is a stopcock that controls the flow rate. Silica gel is then covered with a layer of sand, and on top of this, we place our mixture to be separated. And finally, we continuously add our mobile phase or solvent from the top. Let's consolidate how this whole thing works in a practical sense. It's four basic steps. First, we pack the column. Think of this as preparing the racetrack with a uniform layer of our adsorbent. Secondly, we load our sample mixture, the runners, in a thin concentrated band right at the starting line. Third, we begin the elution. We start adding the mobile phase solvent. This solvent winds through the packed column, pushing our sample with it. This is where the race happens. Our sticky compounds move slowly and the less sticky ones move quickly, creating these distinct bands. And finally, we collect. As each pure separated band reaches the bottom, we collect it into a fresh beaker, giving us pure samples of individual components called fractions. After collection, the solvent is evaporated to yield the pure solid product. Thus, chromatography is the filter of the modern scientific world. Without it, we wouldn't have pure medicines or clean food testing. Forensics uses to analyze complex mixtures for poisons, and in research, we isolate and study pure vitamins from food, or pigments from plants, or even hormones of the body. Now, let us compare it with paper chromatography. While paper chromatography is analytical, tells you what is in the sample, column chromatography is preparative, that is, gives you the pure substance in large quantity. Paper chromatography is based on the principle of partition. Stationary phase is water adsorbed on paper. Mobile phase ascends upwards due to capillary action, whereas column chromatography is based on adsorption, with stationary phase as adsorbent and mobile phase descends downward due to gravity. Thank you for watching.